and a guy realized, another speaker, he realized he forgot his clicker at home. And I was like, here, you can use mine. I should have asked, hey, what time are you presenting? Because we were presenting at the same time.
Oh, no.
And it was the last session of the day, of the last day. So he's going to mail it to me. Because my flight was like right after. I had to, they were waiting for me, and I can't see my preview, so I don't know what come next. I mean, I've done this a couple times, so I know the talk. But all right, as always, definitely want to thank Tech Systems and for the food and Slingshot, at least for a couple more months for the place. And then, sure enough, and you can ask Dan if you've got more questions, because I don't know.
But they're funny we're talking about this. We're currently hiring, so if you're interested in being an AI developer, we've got a position, and then probably talk to David here about the P3 technology developer. You're like initial developer on that project?
I was, yeah.
That's fun. So they are apparently going like gangbusters. So
there might be a spot for you to come back.
Hey.
I noticed how thrilled he was with that one.
I built it. I'm just kidding.
Well, but you can be senior now, right?
Yeah.
And then the senior, you could say, see, this is what the mistakes you make when you're a junior developer, right?
Right. There you go.
All right. Excuse me. So I don't have anything scheduled yet, but I am actually talking to someone. So hopefully either September, October, he'll be here. And he's got a lot of topics that we haven't decided what he's going to do, but really good speak. Actually, he's spoken here before, Rob Richardson, virtually. He'll be virtual again because he's all the way out in Utah. But we are, at least for the rest of the year, third Thursday. I don't have any more. I have travel, but I don't have any more travel that interrupts. Which I have travel. Hey, so come see me, right? Lots of great events. I mean, really, if you are interested in one of the VS Lives, I can save you $500. And I get credit for it, right? I don't get any money out of it. So, all right. And then, we'll be going to Brick House. See, I have it in front of me so I can remember, because everyone knows I never remember that. All right. Oh, those are not sponsors for tonight. So apparently the screen on Twitch is just white. I mean, I can see here it's sharing the whole screen, so that's interesting. Blank screen. Well, let's just do this. We will remove, and then we'll add back to stage. And if you're online and that's all you see, I apologize. You just get to hear my docile tones, which are not that docile. I wonder if it's because it's in presentation mode. I wonder if it's not sharing it correctly because of that. So he saw the infinity screen.
Oh, weird.
I'm wondering if it's because I'm in presenting mode. I don't know.
I mean, if you're sharing the full screen, I would think it would.
You would think so. But it's one of these click things. I mean, it's so, because, that works really well. All right. All right. You all know me. So, sure enough, who's using Azure Functions right now? Awesome. I get to teach everyone about Azure Functions. Okay. Now this is Sean who gets to, you'll see my presentation. I don't really know what else to do.
You just full screen it?
Yeah, what about that screen? Can you do that screen?
I could.
That's good for us, dude.
Yeah.
Yeah.
We like this screen better.
Does that work?
Yeah, we're more in the know. We're part of it.
You're part of it.
Yeah, we
Kinda-
can see your notes.
Kind of miss, I don't know if I actually have any notes in this one. You do kind of miss my, some of my animations are pretty darn cool. this is my whole story of serverless. You know, that it's all about the animations in that one. Well, all right, we'll do this. We'll see. No, we'll do this. I'll just share the screen. We'll see if that works. All right. Well, if no one's doing Azure functions, you're not doing durable functions. All right, which is cool. So what are we talking about serverless? Again, spoiler, you're already seeing it all. So think about like on-prem world, right? You had to figure out, you had to figure out your server, you had to figure out your operating systems, what framework you use. You then somehow got that out in the cloud, but you weren't done, right? All these questions you had to answer, right? Physical security, logical security, how we're going to keep things up to date. Who's going to monitor this kind of things, right? Lots of hard questions that have nothing to do with us building our software, right? But are super, super important. You have to think about these, right? Otherwise, you're just going to waste development efforts. The cloud comes up to be, and the cloud really starts off with this infrastructure as a service, IaaS, right? This was, Amazon. Okay, I'll start my quick little rant about the cloud. The cloud did not start in the 2000s. The cloud started in the 1960s with Ross Perot. All right. Don't presentation at all. I don't know. Okay. I have no idea what that means.
That's the screen right now.
Huh.
So it's,
Yeah, it's just nothing, huh?
well, it's showing some kind of I don't know what screens are.
It's showing okay. Yeah, it's just showing that screen.
But if you point the laptop a little bit this way, they'll see the presentation appear in your video.
Well, yes. I see what you're saying. I do see what you're saying. Okay, come on, Sean. Now, I'm presenting, right?
So it's like
But you're not.
I love Sean, but
Everybody say hi to Sean.
here we can point it to here. You can see behind me. I don't know what's going on.
I was gonna say you could try like if they're seeing that infinity screen, try
The thing is, all they're seeing is. Let's just stop screen. I mean, I'll restart the.
I was just wondering if somehow it was like only sharing like the browser or something.
Entire screen. And if they still don't see it, there's not much else I can do.
We're good?
All right. Apparently he's redoing it. So funny story is I'm about to get rid of that subscription. Because, oh my goodness. I remember so that's StreamYard. And when StreamYard first came out, it was like $100 and some odd a year. They now want $870 a year. Yeah. Guess what we will not have starting next month.
And I assume that they've totally added $700 worth of features.
Well, at least they warned you. I did get an email. Hey, it was basically they were saying that they added features to the lower tier, right? So you can go to the lower tier, but that was still like almost $500 a year. Yeah. All right. So so you got the IaaS, right? So basically virtual machines out in the cloud, and the simplify things, right? I mean, now the virtual machine was out there, and it did organize questions, right? Because the vendors were actually really good about at least giving us white papers and all that kind of stuff. But the questions that, okay, come on now. He's going to say he sees it now. Now he says, I don't know. If you don't see my screen, you don't see my screen. He says it's white. I could open it also, but it is what it is at this point. So So yeah, so we still have, but you still have all the questions, right? It's just organized. So at least you knew more of what you didn't know, right? Yeah, so it was a little bit better. The cloud keeps on moving up, and we get to platform as a service, PaaS, right? So now think of like your in Azure, it's the Azure Azure web apps and that type of thing. And now you're not dealing with the server and everything. You're just dealing with a platform, right? It's kind of simplifying things. And sure enough, a lot of questions go away, right? Because we're not worried about physical security and maintaining the server and all that good stuff. Because you don't touch the server, you're touching the platform. But notice the questions is still left, right? What's the right size? How many of these things? How do I scale this? I mean, as app developers, these are the things that we worry about the most, right? Especially when you get to the architecture world. I mean, that's my whole life is those kind of questions. So, so how do we get it right for them? Well, serverless, right? And again, I'm not saying serverless is the answer to everything, although I've staked my career on serverless, right? But we take away the operating systems. In the serverless world, the most I know, like in Azure, is whether I'm running it on Windows or I'm running on Linux. I don't even know what version of Windows. I don't even know what version of Linux or what kernel. I mean, because with Linux, you got all the kernels. Actually, we do know because Microsoft runs a custom kernel. We're not worried about the operating or the platforms. I mean, obviously, you're still developing against .NET or Python or Java. God help you, right? But we're not maintaining it. We're not having to make sure it's up to the latest version because the vendors take care of that. And really, all the scale questions go out because that's now handled by the vendors, right? All we're worried about is writing code because you're literally putting out small pieces of code to solve problems. And so it makes things a whole lot easier. Now, of course, this name is a little bit silly, serverless, right? Obviously, there's servers, right? And it's not that there isn't servers. It's that you could think about servers less. So, because, we're not worried about server configuration. We're not worried about server scaling. Again, you're just worried about getting your stuff out there. Now, when we talk about serverless, there's really two main things we talk about with serverless. I'll start with the second one, which is back end of the service. So, like for example, I can have a SQL server in Azure, and again, AWS and GCP all have similar things. But I can have a SQL server in Azure SQL, and I can actually have a serverless SQL server. So when it's not in use, it goes to sleep, and it shuts down. Still keeps the storage, but the CPU shuts down. And so like in Jasper, this is exactly what we do because we're a single shift company, right? We have operations from 6:30 in the morning to about 4:30 in the afternoon, and then because there's still some actions, but that one database in particular at about 5:30 it goes to sleep, which means we're not paying for it, during that time, and during the weekends we're not paying for it. So it's really nice. So that's back as a service. But generally, when we say serverless, we're talking about function as a service, right? The whole idea that, again, I'm making a small little function out there and I'm having it respond to triggers. But, so in detail, these are event driven. So, and actually, that is the official term is event driven. I like calling it trigger driven because that's really what you're doing. You have these quick little triggers. Triggers could be something as simple as an HTTP trigger. So I call this endpoint. It also could be something got added to a database. A message got popped in, a text message, right? I mean, all kinds of things that can actually trigger these off. Now, the next is that they're short-lived. There's actually a big tenet when we come to serverless. And what does short-lived mean? Yeah, it depends. But generally, we're usually talking a couple seconds. And also, we're talking about short-lived is that they're gone, right? I mean, there's no memory, there's no state. It's just run that quick little task and then go on to the next task. The whole automatic scaling, right? I mean, the whole reason why I first looked at these, right? I needed something that could scale, because the company we were at, we couldn't spend the money to just have servers just waiting. but we also couldn't afford to have people waiting, right? And that's what you get with that automatic scaling. And literally, by default, you can just do nothing. And it's cool to watch it, right? Because you can actually watch the metrics, and I can spin it up, and I can see it as 0. And then within 5 seconds, I've got a server up and running. And within, I do enough hits, within a minute, I've got like 30 servers up and running, just handling my responses or my requests. They're generally based upon per execution. When we talk about serverless, it's generally what we're talking about. Not all are, right? I'll talk about that like with Azure, but generally it's what we're talking about. And then finally, the abstraction infrastructure. Because like I say, I know some more stuff because I know the people who built Azure Functions. So I've got to learn some more how they build it. But in general, we don't know how they build it. We don't know what kind of servers they're running on because we don't need to know. All right. And again, that's the whole big benefit of that. So we were talking about serverless in general, but what about Azure Functions? All right. So Azure Functions is all about taking your code and your events and data and then putting those together. And I've always loved that animation. The first time I saw it, I've stolen it and used it in so many presentations because I never realized that's what the logo meant until I saw that. But that's their whole idea, right? And like I say, this is Microsoft's answer to the functions of service. As you've probably heard me say before, if you're ever trying to figure out what the name of an Azure service is, it's probably whatever it is. What's the functions of service? Azure Functions, right? What's the service bus in Azure? Azure Service Bus, right? They're generally pretty standard on that. But some big features with Azure Functions. One is choice of language. So you've got the obvious, the C#. I mean, that's the most obvious. Although I got to admit, I actually had someone ask me, is it normal to do C# in Azure Functions? And I was like, yeah, that's probably like 85% of the market. But so C#, JavaScript, F#, but also Python, Java, TypeScript, and even just Bash. And one of the cool things, and this is still relatively new, last 2, maybe 3 years now, they've guaranteed parity across all the languages. That didn't used to be the case. Obviously, C# was almost always ahead, right, because of obvious reasons, right? But even that wasn't always the case. There were some things that, like Java, was ahead because of the way how they designed Java. Let's not get Microsoft in trouble with them designing Java, but the way how they design Azure Functions for Java. So you got, so it's really nice. You can use these all languages, which again, one means different types of teams can work in this. But I went to work for a company and we were doing some machine learning stuff in Azure Functions. And we had a guy who was really good at Python. I'm like, do that in Python, right? Because that makes sense for what we were building. Next big deal is the whole bring your own dependencies. So sure enough, to me, this is a critical linchpin of Azure Functions. So I can have my packages in NuGet, my JavaScript packages in NPM. The reason why I'm a big fan of this is because this is also how to tell you really should write your applications. So my Azure Functions have almost no code in it, right? They're calling packages, right? And the big reason is because you can't actually unit test an Azure function because of the hosting model of it. But you can definitely test a .NET package or any other kind of package. So simplified integration. So good. I didn't have it all click once a month, But so whether you're going to do a Cosmos update, right, or like a service bus message coming in, or files getting added to a blob store, right? They made this just really simple. And honestly, and I've said this before, if you look at the 3 main clouds, right? You look at Amazon. Well, I'll start with Google first, right? Google is Google, right? And it's all heavily computer science engineer focused, right? It's the whole reason why they love their products but don't love their products. They love them because they're free, but it's always so complicated to use because that's they wrote them from themselves, right? AWS is network focused. Network folks love AWS. Software developers I won't say hate AWS, right? But comparatively, right? Microsoft is a development company first forget the fact is we got Windows and Office that make them all the money, right? But in their nature, they're a development company, right? So they make these kind of things easier. But the cool part is, I mean, here we're talking about these Azure services, right? But also things like RabbitMQ. Yes, GitHub is now owned by Microsoft, but as Arissa will quickly tell you, they are not Microsoft.
It doesn't come off as being like, well, I won't say entirely like as not being Microsoft.
Yeah.
But
Although
they do.
the new leadership change really is making that even more fuzzier.
It's kind of an interesting experience because it's kind of like, with the exception of Copilot, it feels like at GitHub it's fairly like left to its own devices.
Yeah, but just like,
within some compliance.
I mean, he's not leaving till the end of the year, but the CEO is leaving, and leadership's going to fall in right underneath Microsoft. But to the point of this, right? There's lots of third parties that Microsoft works to build these out, right? So it's not like you're dependent on the third parties, because they realize the way they sell their products is by ensuring you can tie it with these other projects you're going to use. But also, so that's all the trigger types, but also bindings. So making it real easy. Say I have an HTTP trigger, and on that I want to go query a Cosmos database to go get a value right away. And make this. I literally just add an attribute. Tell it, hey, here's the name of the Cosmos database. Here's the name of the container, and here's like the ID that I most likely from the query or from the query string or something. Make it really, really simple. And again, you see lots of Microsoft products, but also, a lot of parts you won't see. The data factory is an interesting one, right? If you're needing to do a lot of data manipulation. But again, third-party bindings, and you can do custom bindings. They're not the easiest thing in the world in the write, but you can do it. And it is possible, right? When I say it's not easy, it's just, you have to think about it. So, all right, and then, again, I don't have my clicker, so just move it along here. And then flexible development, right? So you could write your Azure functions in the Azure portal. Again, please don't do that. We have nice tools to do that. But Visual Studio Code, I can just use any editor because there's the CLI tools, but also they tie to the normal stuff for code repositories, your GitHub and Azure DevOps and Maven, but Bitbucket and regular Git repositories. And one of these days I will try this, but you can do it like with a OneDrive. I don't know why you would ever want to keep your source control in OneDrive, but you know what? Microsoft actually built it so that when you check the files into that OneDrive, they will publish it up into the Azure function. I don't know why, but they did it. Someone probably challenged them. And then the other really big feature is all the hosting options. And again, this is something that really differentiates Microsoft against the others. So they have consumption, right, which is your true serverless. All right, this is a whole pay as you go. When nothing's being processed, it completely goes to sleep. The moment something hits it, it wakes up. All right. You get, your first million transactions are free, and first what they call gigabyte seconds, first 400,000 gigabyte seconds. So how much memory over how long of a period of time you're using for it. All right. So a really nice service there. Several years ago, they added premium, and premium is premium for several reasons. One, it is using better CPUs, more memory, right? So it's premium in that sense. But notice I put sort of serverless. So on the premium, on the consumption, it goes to sleep, right? When there's no hits, it goes fully asleep. And the one problem with that is what's called cold starts, because it takes it a moment to start back up. And the funny part is .NET's one of the worst. .NET takes forever to start up in an Azure function. Also in AWS Lambdas and so forth, right? The premium, you're guaranteed you always have at least one instance always running. You also pay it. There is a premium price, right? So that I can have a a consumption function that doesn't run at all during the month, and I pay $0. I have a Azure premium function that doesn't run at all, and I pay $155. So there's definitely consideration with that. Now that's also very static costs. So so if you are doing a lot of transactions, it could eventually save you money, just depending on what you're doing. But also, they have dedicated, they have container apps, whole another really interesting story, and then a bunch of others, right? To include, if you got tons of money, you can have the Azure Stack, so you can actually run Azure in your own on-prem environment. But notice also your own server. You can actually download the host engine and run on your own server. And technically, when you do local development, it's exactly what you're doing, because you're not running an emulator or anything. You're actually running Azure functions. So there's the only limitation on the local they don't even call it emulator. The local tools is that it only allows local host. So you're not going to actually be able to put your laptop up on the internet and start taking actions for that. But you can download the regular host and do all those kind of things. So lots of great options that we have for a long time. But now this is a year old now, but they came up with flex consumption. And I still have kept this in a separate slide because this is really a game changer, right? So this sits in between the consumption and that premium, right? So like, for example, at Jasper, we're doing all this stuff. We need everything behind a virtual network, right? Because we don't want anyone getting into our stuff. We don't want an open internet. Consumption does not support that. You had to go to premium. That was a really expensive bite just to be able to get security, right? Flex consumption includes this, but it's priced more like the consumption base is, because it does go to sleep. Actually, you can do a 0 or more, because it has a whole always ready is what they call it. So I can actually keep one alive. It's really interesting how they've done it, because the pricing is just amazing on that. So, and sure enough, I don't know this for sure, but I think they're trying to get rid of consumption and go to the flex consumption, because it really is just better anyways. And then the final big feature of Azure Functions, like a lot of things in Microsoft nowadays, is it's open source. Now, the reason why I say this is a big feature, right, is not that, oh, great, they share the source code and all this kind of stuff, which is cool, right? If you ever want to see just how hard it is to do serverless work, go read this source code, all right? But more importantly, when you get stuck with a real issue, right, and the help desk doesn't help you out, put an issue on here, and they will, you'll actually get the actual team responding. Now, don't put stupid stuff on there, right? But actual issues, and they will respond. So, so if we look at just the simple Azure function code, so you can see what it looks like. So number one, it's just a class, right? Actually, it's a method inside a class. So I just have a record class. Here you can see I have my logger. And like I said, it's just a method. And here I've got an iAction result with a run. So I talked about the triggers. So here we can see the HTTP triggers in here. The authorization level is exactly what it sounds like. The route, so this is an HTTP trigger, so I can actually have a route in there. I'm getting an HTTP request. Now, what makes this is not an Azure function yet. This is what makes it an Azure function, is that attribute that says this is an Azure function, and I give it a name, all right? And then, whatever code I need in here. You'll notice that there's a lot of similarities to ASP.NET. It's because it's actually running on the ASP.NET engine. Well, it's no longer running on the ASP.NET engine, but it's still based off the ASP.NET engine. So there is a lot of similarities, which is really nice. All right, and as far as the function app, so so you have a function, and then you have a function app, which is technically 0 or more. An Azure function app with 0 functions is not very useful, but 0 or more Azure functions. So you can have HTTP triggers, you can have timer triggers, you can have server response, you can have SQL, all these different type of triggers in there, and these are different functions. You cannot mix triggers, right? So I can't have one Azure function that is triggered by both a timer and a HTTP trigger, right? generally what we do in those cases is, again, we have that centralized code because there are times they need that, right? Like, for example, in my teams, whenever we do a timer trigger, we always have an HP trigger so we can manually call that whenever we need to. Because you always find out, you always need it to run manually at some point. Now, prior to flex consumption, it was not a good practice to mix triggers together in one function now. And the reason is because they all scaled differently, right? Because remember, this is all about scaling, right? And so, for example, they made some decisions. And so the HP trigger did not scale as fast as the service bus triggers. And the reason is because generally, I don't get just one message. I get a lot of messages all at the same time, right? Whereas, HP triggers, you generally don't get as much traffic as you would on messaging. And so what would happen is, again, I talked about you pay for those gigabyte seconds and all that type of stuff. Well, because it's scaling up faster, you're using more servers. So you are going to start paying more because there's more gigabyte seconds being used. And so you ended up, paying more for that in some instances, right? Now, bring those all up. One of the things that they fixed with flux consumption is, you could always mix them. You just had that concern. But now they actually do independent scaling. So a service bus scales separately, right? So it's kind of like having mini apps inside of your function app. So I've really gotten to the point. I have no use for premium functions in my role, right? We never run anything that needs that much more memory or anything. So, all right. So really quickly, we've been talking about Azure functions and some key points, right? Because now we get to durable functions, right? But they're stateless, they're short running, event triggered, and serverless computing. So those first 2 points I want to emphasize, right? Stateless and short running. Because this obviously means there are things I can't do, right? And workflows are the ones that get really hard with Azure functions, right? Because there's no state. I'm not keeping track of where I'm at on a workflow. They're short running, right? Well, what if I need something that's going to take longer to run, right? Have a lot of steps in it and such. And that's kind of where we get, right? I already said this. How do we keep track of things? Bless you. How do we have some type of management of this, right? And that's where, like I say, durable functions come into place. So this isn't something different. It's an extension on top of Azure Functions. So you start the whole, your C# app or whatever, right? Starts the exact same way. You just end up adding another library into your project. So it's an extension. And the important part is it lets me write these stateful functions in a serverless environment. So I write that purposely. It's not like you're all going to all of a sudden in there keep your database of all your data, right? What is the stateful part is that it's keeping track of where you're at in the process. We'll see some more of that here. And then finally, defining workflows in code. So, this is the reason why I love durable functions. Because generally what you'll have is, you'll have these processes that need to do like 6, 7, 8 steps, right? And, there's plenty of workflow tools out there. And they get really complicated so hard because they want to hide everything from you and, have this nice GUI and everything. It makes it so easy to build until you actually need to try to work with it, right? Here it's just code. And we'll see it's not complicated code. It's actually very simple code that they're using to do this. So the basics. One, you define your workflows in code, right? You have parallel execution, you have error handling in there, and you have what they call orchestrator functions. It's what's orchestrating all these things that happen. It supports a lot of different patterns. Oh, there it is. And we'll talk more about those patterns here in a moment. And again, solving that state problem. So like I said, the hard part about trying to do workflows with regular Azure functions is because there was no state. And because you got to remember, every time I hit an Azure function, I could very well be hitting a different server every single time, right? Because if I have a lot of hits, it's gonna span my app across a bunch of different servers, physical and virtual. Whereas here, and actually technically what it's doing is containers. Is actually how Azure Functions work. But here, like I say, it has built that in, because I have tried to do it before, right? Where I built my own state and it didn't work so well. They've solved that problem. So, other parts of this, I talked about defines the workflow and code. Like I say, we'll see the code. It's pretty easy to implement. But again, exception handling. Generally, what I've seen, when I've used some of the other nice, quote unquote, nice workflow tools, they don't even have time to even think about exception handling. It's always happy path. Well, as we all know, life is not always happy, right? It's just not the way the world works. There's also really easy ways to check where am I at on this thing, right? What's the progress of this? Or to cancel workflows, right? Because again, that happens. And then again, it manages the state for you, right? You don't have to do anything. Literally, you don't have to do anything. All right, a couple of key concepts. So, and I mentioned this. So the orchestrator functions. These are your pieces of code that orchestrate. The name says it all, right? It is your workflow. So it's the one that says, okay, I'm going to do this. I'm going to do this. If if this, and we're going to go off to do this type of thing, right? So that's exactly what it's doing. Next, you have your activity functions, or your workers. So, a couple of things. So orchestrator functions are not triggers, technically, because they have to be triggered by something else. That's actually the next part. And activity functions can only be called by orchestrator functions. But like I say, they're doing the work of everything. And then, as I was just alluding to, then you have the starters, right? So that will be like your HP trigger or a message bus trigger. So like at Jasper, we have a bunch that starts off of a message bus, right? So a message comes in, and then we fire off work based upon what's in that message. So generally workflow, right? So you have your client function, that starter, that will call the orchestrator, and like I say, that orchestrator will call an activity, and then get a response back from the activity, and then maybe call another activity. And again, you could just have one activity; you don't have to have multiples, and get that response, and then do whatever it needs to do with it. So some constraints, and there's a reason why I'm blinking, and I know the UI or the accessibility person is mad at me for blinking text on the screen right now, but I do it on purpose, and it's purposely ugly. This is the ugly part of durable functions. So the way how durable functions work is they start a process, and then they'll run code until they get to basically to an async, right? And then that orchestrator actually goes to sleep for milliseconds, right? But it goes to sleep. And then it'll come back and it'll check, where are we at? Is that task done? And if that task is done, it'll go to the next task. If it's not done, it goes back to sleep and then wakes back up. So this is where you have problems. So you have to make sure you're using these deterministic APIs. So what I'm talking about, date times, random numbers, GUIDs. Because what happens if I just use the regular date time? Every single time that code runs, it will generate a new date time or a new random number or a new GUID, right? So what the Azure Function team did was they built these deterministic APIs, right? So it builds safes date time. So once it builds the date time once, it's used the whole time that state is running or that workflow is running. And I think so date times, GUIDs. So we can see a lot of things in here, right? So you have to, that's one of the big things you have to think about. And since I'm talking about things that are hard in durable functions, debugging is one of the hardest things because it's all asynchronous work. So you put a debug code in and you're on that line, you're trying to figure out what happens. And before you can even click the F10 button to go next, it's already started that whole process again. Hence, move your code over somewhere else so you can debug it in a more natural way. So, all right. So I alluded to this a little bit, but the application patterns. right? So what kind of things can we do with these, right? We've been talking about workflows, but what do we mean by that? So first one, function chain. So the idea, I have a function, it does something, it calls another function that does something, calls another function that does something, calls another function that does something. Now, I can do this with a regular consumption app. But remember, I talked about durations and everything. In a regular function app, when function 1 runs and calls function 2, it's still running. And when function 2 calls function 3, function 1 and function 2 are still running, and so forth. All right? Whereas here, they're just activities within there. You're literally only paying for the time that those individual things are running instead of the overall time. All right? So this is a very common pattern to happen. I mean, we do this all the time in durable functions, and now we can do it effectually, right? So things like process, order process, process payment, do order validation, do reserve inventory, image processing, another great example of using this, right? Resize it, filter the image, store it, data migration. I thought I already said data migration. Come on, there we go. Approval processes, but I'm going to get to this one. Think about report generation. So we need to collect data. We need to collect some more data, process that data, generate the report. So how would that look like in a durable function? Well, one, graphically, we can see we'll have these 4 activities, and they're wonderfully named. Fetch data, fetch more data, right? This is demo work, not real work, right? Process data, generate a report, right? So you got these 4 activities. Again, I'll have my orchestrator that's responsible for calling those activities. So it will call it one by one. And then I'll have my starter that basically starts off this whole process, all right? The cool part is how it looks like in code. So here's our activity, right? So fetch data from location 1, wonderfully named. Please don't name your things like that. But you're getting an example. So again, we'll see it's a function, right? Just, it's got that function attribute. It's still doing, it's returned a task with a list of strings. Notice it's got a activity trigger. And again, you can only call activity triggers from an orchestrator. Another important part is I get the function context, which gives me exactly what it sounds like, the context of the running function in there. And then here, we're just simulating doing some work, right? But I can return data, right? And that's kind of the important part. Oh, okay. Call out what I just already called out. Oh, yeah, another important part. Notice, so when I'm trying to get a logger, I'm asking from that function context. Because again, deterministic APIs, right? That's part of what that is. Here we can see the fetch more data, process data. These are just all kind of a little the same, except for in here, what am I trying to show differently here? Oh, here I'm actually sending in data, right? Because it's basically, we're sending in the 2 different sets of data. And then generate report. And here you can see I'm saving to the blob, right? Nothing in particular with that. So here's the orchestrator. And this is what I'm talking about. So these 4 lines here, and I probably highlighted this in the next animation, but these 4 lines here are that workflow, right? So get my data, just call async, right? And again, like I say, what the engine does is it gets down to that first line, says, okay, I'm going to call this async. I'm not going to wait. So this is going to go to sleep until that's done, right? Although, like I said, it doesn't actually go to sleep completely. It'll keep on checking because it's looking for the checkpoint of where it's at. But when it does that checkpoint, it literally is rerunning all the things. The logger is actually different because notice I have a replay safe logger. Again, deterministic APIs. So it will only call that start reporting generation once. But yeah, it'll do all these things and then returns it. So that's what I'm saying. That's pretty simple to define a workflow. And then here's our starter. And again, no one said they've done Azure Functions before, but we talked about it. I know I have some animations here. So again, I'll have my HTTP trigger. So that's just like I showed in the Hello World. It's an HTTP trigger. With some different things here. And one, I have this binding for a durable client. All right, so it tells it this is going to be a durable Azure function, or the starter of one. And then the client.schedule new orchestration instance async. They're not worried about verbosity. I still loved it. When it was still VB versus C#. And of course I came from the VB world, so I was like, why don't you like, VB? And someone said, well, VB is true verbose. And I'm like, I type 130 words per minute. What am I worried about verbosity? But at any rate. And then finally, what we're doing here, because we're going to create this, create check status response. Because the starter's done, but what that'll do is actually return me some nice links. All right. So we start this up. Again, we'll see, so we still have our hello world in there. There's everything that makes up this durable function, which I will tell you, I also recommend each durable function, right, with all its activities and such, you should put that in its own function app. Your life would be a whole lot easier, right? Because it's a lot easier to figure out, oh, that belongs to this one, that belongs to that one, right? If you just have it all in one function app. But so if we call this, and I apologize, that's kind of washed out. But I'm calling the local host on that. And here's my response. And so I get a bunch of URLs. So we can see a purge history, a send event, status. So I can get the status where we're at on it. I can terminate it. I can suspend it. Actually, I don't have much luck with the suspends. But here I'm showing I get that status. So if I was to go to that link, I'll see a thing. It'll tell me, okay, it is running, right? So that's the important part. If we call this thing again, after it's done, it'll tell me it's completed. So again, I'm getting statuses. I don't have to do anything for that. It's all built in, right? Which means I can easily give that to a customer, right? Now, obviously, I mean a customer as someone who's an API type thing, right? Who can then call that and query it and see when that process is done. And here you also get an output, right? So, which was, there was the output. A wonderful report. Beautiful. So that's the function chain. Now the one I really like is the fan out, fan in. Think about when I need to take in some data and I need to do a lot of things with it, right? Or it's a lot of data that I'm doing similar type processing. And that's what the fan out, fan in is all about. So the whole idea, your starter function comes in and literally it's doing an operation, but it's using Azure function. The whole idea that it'll scale out. And so it says, okay, here's all the tasks I need you to do it, right? And it'll just scale it out. And then the important part is to scale it back in and return your response. And again, that last part's actually optional. So think of things like batch processing, stock price analysis, rendering videos, concurrent API calls, or the one we have in here, web scraping. I did write this before AI became the hotness. So we could write the things so that AI could steal all our knowledge, right? So what's our solution look like in web scraping? Well, graphically, we're going to have this, just one activity we write, scrape web page. We'll have the orchestrator and we'll have the starter, right? So I'm hoping I'm saying or remember this correctly. Yes. So the starter we'll call the orchestrator, and then notice the orchestrator said, okay, I got all this work. Basically, it got a web page, it got all the URLs out of that, and it says now go all those web pages, right? And it just, created a whole bunch of Azure functions to get that job done quickly. So here in this code, what we're looking at here, we're looking at the scraper itself. It's an activity trigger again. Am I highlighting things? No. And I mean, again, there's nothing in particular with this, just the fact that you've got another activity trigger in here. Here's your starter. Again, there's a little bit more coding here because I'm feeding in some data, but the basis of it is the same. Here's your orchestrator. And this, what I've got highlighted here is the key of making this a fan out, fan in. So I'm creating a list of tasks that have a key value pair. And I'm, basically I'm sticking all the URLs in that list, right? And then in the next part, the win all is the key part. That's what actually starts the whole fan out, all right? So it's exactly what it says, right? Do all these tasks, and when all these tasks are done, basically, complete that statement. And again, using the power of Azure Functions to scan that out. And then I get a result that I can read. And again, this last part, you don't always do, right? It's if you need the results of that, you can do it, right? And so that's one of the big benefits of it. All right, next one. Async API. Sorry, I'm actually trying to get, I've been talking all day. Async APIs. So the idea of I need to do a long running process, right? My whole job is trying to migrate, 38-year-old applications to the cloud, right? And guess what? We can't do that all in one day, right? So we have a lot of things we call back to legacy, and those things take time to run. These are a perfect example of that, right? So in here, I can start to work, I can do things, I can do that work. And the important part is I also get status of that. So, and then, again, keeping it, and I'm not doing that bottom part. That's what Durable Functions is doing for me. And I can get a status of this, right? So, lots of examples. There we go. Well, think of like your long-running database operations or long-running legacy application, right? So in here, again, your starter will call off. I mean, it's pretty simple in here, but what gets added in here, I didn't put that in. I thought I did have something extra. But what gets added in here is the fact that I've got the status, which we saw before. This pattern is actually really using things we've already seen before. Here's your starter. There's nothing special with the starter. Here's your orchestrator. And again, there's nothing really different. I mean, I'm just calling an async method, right? It's just that everything is built in here, right? Because I literally encode wait for 30 seconds for a response. So point being is I didn't have to do anything to then get that status like I was showing in the Postman earlier on, all right? Another really nice one, monitor. So something that happens a lot that we do in Azure Functions is the timer trigger, right? The whole idea of, run every 30 minutes or run on the 5th hour of every Tuesday, right? I mean, you can do all these kind of things. It's all cron-based, timer situations, which never asked me to how to write those things. That's what Copilot's for, because I never can remember the syntax for those things. But what happens if, let's say I'm running it every 5 minutes. I've got a 5-minute timer. What happens if the job's not done within 5 minutes? Is it okay to start another? Because by default, it will. It will just start another instance of it, right? And that might be fine, right? It might not be. Or what if I need that timer to be variable? So in Azure Functions, regular Azure Functions, there's a very nice timer trigger, but that value is hard-coded, all right? You cannot set it outside. It is set in the startup of the function app. So once that function app is started, it's set. But what happens when I need to change it, right? What happens when we're doing like an alert type system where we want to run every hour in normal, but when things go wrong, we want to run every 5 minutes. These are the kind of things you can do with this monitor. So you can see some good examples, but website availability monitoring, right? So again, starter, orchestrator. You can see I've got my check status. I've got my send alert, right? When things start going wrong. And that's what I'm trying to show, that can be called conditionally and change the timers on them. And this is a lot of text on there. I skipped over it. Here, there's a lot of text, but because we're doing some table client stuff and such, right? That's not the important part. And even here, we're sending alerts. I did want to highlight a service most people don't know. There's Azure Communication Services, which actually is kind of a nice service. It's their competitor to Twilio. But here's my starter. Again, nothing new here. But orchestrator, do I highlight this? Yes. So in here, you can actually see I'm able to set times in here. Right in here, I'm just doing add 24 hours, but I can have more logic to do those. And notice at the end of that while loop, again, I could change these timers, right? Because there could have been some type of condition. Like in here, I'm setting the check interval, which I know somewhere in this code, I changed that value. I don't see it right this moment. Well, it's up top. But you can kind of see the idea of what we're doing here. All right. The last useful, but not the last pattern. You'll see what I mean when I get to the last pattern. But it's human interaction. And don't get stuck with the name human. All right. But the idea, think of like a request approval, right? You send it to a human to get approval. And, what happens, what should happen is Bob approves that, right? Well, what happens when Bob doesn't approve that, right? An hour goes by. Well, we can have escalations, right? So we can literally say, okay, this has been waiting for an hour, and let's do whatever we need to do, right? Send it to Sally or what have you, right? So approval workflows, expense reports, support ticket escalations, survey feedbacks, or one of the most obvious ones, if you really think about the user registrations. Think about the whole, you sign up for a website, and then they email you a code. You got to enter that code within 5 minutes and all this good stuff. So it's a perfect example of using this. So again, the starter we'll call the orchestrator, which we'll call that first activity. So it'll send an example, in the code example, it sends an email, right? And there's a HTTP link that you can call back. And then that will actually record the challenge status, right? So here's our orchestrator. This gets, do I have? Yes. I was trying to remember what I had here. Again, I can't see my previews. So a couple of things to point out here. So here, we're gonna create a safe logger. Notice that I'm getting the email address, and I'm going to record this. So I'm recording my own state of what was the challenge value, right? So, because that's what we're trying to do in this example. Next part in here, a little bit further down, here's where we're actually setting a timeout on here, right? The escalation period. So in this example, we have a challenge timeout second, which I think I had it set for 300 seconds, so 5 minutes. And then we're literally creating a timer in here with this. And then finally we get in here. So you'll notice, you got 3 tries. So can you put your code in correctly within 3 tries? And no. And the important part is you'll notice if it's a winner, right? So it matches. Well, then we're going to, we're going to save that. But then the important part is here, we're going to call that record challenge status, right? So it's done. If it doesn't, and we get a timeout expired, then we'll see that challenge timeout. All right, so that's that one. So the last one, and I don't like this one because it doesn't really work. Again, in my opinion. The Microsoft team would probably greatly disagree with me. So the aggregator. In theory, the idea here, think of like aggregating values, right? like I mean, again, when I say I never get to work, I never get to work in a real scenario. I've gotten like the examples to work, right? So like one of the examples I saw a long time ago was like a step counter. And so every time a step would happen, it would, you could call that function, it would trigger it and keep that count, right? That's basically what we're doing here, all right? Yeah, it's there. I don't even have, I gave scenarios, yeah. Weather aggregation, sales data aggregation, log data aggregation, so, your different type of aggregations. I don't have code samples for it because I don't want to waste my time with it. That's how I feel about that one. So, and I will say I'll have the QR code here in a moment, but all the code is in my repo. All right, a couple additional details real quick. So we've been talking about orchestrators. What happens when you have a big orchestration, right? And you get a lot of code. Well, we're taught we should break code apart, right? And that's, they have the idea of sub-orchestrations, right? So I can have an orchestrator that basically calls other orchestrators, right? So I can kind of divide that work up, right? And again, when you get to more complicated workflows that have a lot of steps, this is really, really nice. Custom statuses. So here we can see in this example. So this is actually the hello world example. That, if you go in Visual Studio and say create me a new durable function, this is the exact code you're going to get. Excuse me, it's a function chain, right? So it's going to call 3 functions in a row. And if I was to call this is what I'm going to get back, right? So I see it's running, but where is it at? Is it on the first one? Is it the last one? No real idea, right? I just see that it's running, which is nice, right? But they've added this set custom status, and I can set it to whatever I want because you can see it's just a string value, right? So I can set that in there, and then once that's in there, when I call this, I can say, okay, I'm on Seattle, right? Or I'm 2/3 of the way through, or what have you, right? So it's very simplistic for a reason, but it's really powerful, right? Because it gives me a lot of power to do some things. Internal orchestrations. The idea that I need something to just always run. So a little bit different than the modern one because the modern one technically always runs. But this is just basically, do your work and then continue. Just start over, right? Do it. Just keep on going. You do have ways of actually canceling them and so forth. But so that's a nice little thing. All right, some best practices. This is the last part here. One, and there's a reason why I write this down. You do pretty much always want to use the latest version of the SDKs. Because of the nature of this, they have a tendency to find security issues and performance improvements. So I do generally highly recommend using that. Test it first. Don't just upgrade it and then put it in production, right? The code constraints. So those deterministic APIs, right? Because it sounds like a small thing until, what happened to that date time? Why does it keep on changing, right? What's this crazy value, right? Some things, your Azure function, the durable function just, will go crazy. You do want to try to keep your inputs and outputs as small as possible. If you need big inputs, you need big outputs, right? Use more of like the claim check idea that I talked about a couple months ago, right? Put it somewhere and then send a reference to that and then have the durable function go out and get it. And same thing for sending it back out. And this has a lot to do with just the way how the engine works. And there's no technical limit on how much you can send and receive, but you get some wonky things when it gets big. And what is the answer? What is big? It depends. All right, there's no straight answer to that either. Keep your entity data small. That's the aggregator thing. Don't do it. Invest in stress testing. So this seems like a no-brainer, but the whole idea of this thing is it's probably going to get hit a whole lot of times when you get it out in production. And I've just seen it so many times. And it seems like the durable functions have worse with this, where oh, well, it worked when I ran one message through it. It worked just fine. What happens when all of a sudden I put 1,000 messages a second through it? Again, because of the async nature of it, you can get some weird, wonky things. So you definitely want to do some stress testing with this. Oh, and I thought I had the other part. The other, not really best practice, but again, the remembering, like I say, put your code somewhere else, right? Obviously your whatchamacallit, your orchestrator code has to be an orchestrator. But like your activities, just like I said earlier, at the beginning, I was talking about Azure functions. My preferred is to not really have much code in the activity to actually call out somewhere else so that I can test those individually. Because once you get into an async loop, yeah, good luck trying to keep track of where you're having those things. So, yeah. So that, not bad. That's only an hour and 10 minutes. I thought I'd been talking longer.
This is where we go, yay!
Well, any questions? Well, cool. Well, I'm ready. I'm ready for a beer.
Now they're talking.
Yes. Well, that's the right thing to clap for. All right. And again, I have no idea if anyone online saw anything.
Yes, I was on it most of the time.
Cool. Oh, I did. I do finally see. There you go. All right. For everyone online, thank you so much for joining. All right. We'll end that. Yes, I said